Welcome, everyone. I'm excited to kick off today's presentation on the condensate drainage principle. We'll be exploring essential guidelines to ensure proper drainage in HVAC systems. On this first slide, I'll briefly introduce the key points, including maintaining a 1 to 2% slope on condensate lines, using PVC pipes of at least 3/4 of an inch, and installing P-traps for negative pressure ducts. Stay tuned as we dive deeper into each of these important topics to help you improve your system installations. Let's take a look at the cassette AC drain setup. When setting up the drain, it's important to use lift-up drain pumps that are 750 millimeters or less in height. This helps ensure proper drainage without requiring excessive space. Next, make sure to insulate the drain lines. Insulation is crucial to prevent condensation and potential water damage, especially in cooler environments. Finally, before we close up the ceiling, we need to test the entire drain system by pouring at least 1 liter of water through it. This step helps us verify that everything is functioning correctly and that there are no leaks or blockages. Remember, these details are key to maintaining a reliable and efficient AC system. Let's talk about the concealed ducted drain design. First, it's crucial to maintain a slope of about 1 to 2%. This gentle incline ensures proper drainage without any standing water. Next, I recommend adding cleanout tees every 6 to 8 meters. These cleanouts make it much easier to inspect and clear any potential blockages down the line. It's also important to include a secondary pan and a float switch. The secondary pan provides an additional layer of protection against leaks, and the float switch can automatically shut off the system if water accumulates where it shouldn't. Finally, always test the system by running 2 to 3 liters of water through it. This test verifies that the slope, cleanouts, and safety devices are all functioning correctly. By following these steps, you can ensure a reliable, efficient, and safe concealed ducted drain system that aligns with the overall goal of safe and effective drainage. Now, when installing the indoor units, whether we're working with split systems, cassettes, ducted units, or VRF systems, there are some key points to keep in mind. First, it's essential to mount the indoor units level. Ensuring proper leveling helps the system operate efficiently and prevents any drainage issues down the line. Next, we need to maintain a clearance of about 150 millimeters around the unit. This space allows for easy access for maintenance and proper airflow. Speaking of airflow, it's critical to isolate the unit from any vibrations. Vibration isolation not only reduces noise, but also prolongs the lifespan of the equipment. Finally, always double-check the airflow direction. Correct airflow ensures the conditioned air is distributed effectively, providing comfort and efficiency. By paying attention to these details, we make sure the installation is solid, efficient, and long-lasting, key themes that underpin the overall success of any HVAC project. Now, let's talk about installing the outdoor unit for split or VRF systems. It's important to start with a solid foundation, so we install the unit on an RC base using anti-vibration pads. This helps to minimize noise and vibrations, ensuring quieter operation and protecting the unit. Next, we need to make sure there's at least a 1 meter clearance around the unit. This space is crucial for proper airflow, maintenance access, and overall system efficiency. When setting up the base, it's also important to slope it slightly, about 5 millimeters, to facilitate drainage. Proper drainage prevents water accumulation and potential damage to the unit. Before we move on to charging the system with refrigerant, we must perform a pressure test. This step is vital to confirm that there are no leaks and the system is sealed correctly, ensuring reliable and safe operation. By paying attention to these key points, we help ensure the outdoor unit functions efficiently, lasts longer, and integrates smoothly into the overall system. Let's talk about the refrigerant piping installation for split and VRF systems. First, it's essential to use ASTM B280 copper tubing, which ensures quality and durability. When installing the lines, make sure to insulate both the liquid and suction lines, typically with 10 to 13 millimeters of insulation. This helps prevent energy loss and condensation issues. Next, during the brazing process, it's crucial to do so under a nitrogen atmosphere. This prevents oxidation and ensures a clean, strong joint. After installation, always perform a leak test at 450 psi to confirm there are no leaks in the system. Finally, conduct a vacuum test at 500 microns to remove any moisture and air, ensuring the system is properly sealed and ready for operation. These steps are key to maintaining system efficiency and longevity, which ties back to our overall goal of reliable and efficient refrigerant systems. Let's quickly review the key steps for refrigerant piping installation. First, it's crucial to verify the slope of the pipes to ensure proper drainage and flow. Next, check all traps to make sure they're correctly installed and functioning. Insulation is also essential, so confirm that all pipes are insulated properly to prevent energy loss and condensation. Pressure testing comes next, where we pressurize the system to 450 psi to identify any leaks or weaknesses. After that, we perform a vacuum test at 500 microns to remove any moisture and air, ensuring the system is clean and ready for operation. Finally, a water test involving 2 to 3 liters of water helps us confirm that the system is sealed and there are no leaks. Remember, each of these steps is vital to ensure the system operates efficiently and reliably. By following this step-by-step process, we can maintain high standards of safety and performance throughout the installation.